So in this lecture, let's practice naming some cycloalkanes. Cycloalkanes are alkanes in a ring. So here I'm showing you the 6-ring structure. The same rules as naming alkanes apply here. Identify the longest carbon chain. The special rule here is that the ring is its own chain. So for example, right here, I would count 1, 2, 3, 4, 5, 6 carbons in the ring, and that's a 6-carbon chain. You can never count 6 carbons in the ring and continue going outside of the ring. So here we have a 6-carbon ring. So this is a 6-carbon chain. And then outside the ring, we have a shorter 3-carbon chain. So in this case, the parent is the 6-carbon alkane, hexane. However, because it's in a ring, we'll call this cyclohexane. We have one substituent. It's a 3-carbon chain, and we'll call this propyl. We want to number the parent chain so we can tell the reader where the substituents are located. But there's a special case here. Because this is a ring and there's only one substituent, clearly the substituent must be at carbon number 1. So usually for these mono-substituted rings, there's no need to say 1 propyl cyclohexane. We can simply just name this as propyl cyclohexane. Let's look at the second example. Again, we have a 6-carbon ring. So the parent here is cyclohexane. And branching off of the ring, we have the smaller 3-carbon chain. Notice that the ring is bonded to the center of the 3 carbons. So this is the alkyl group isopropyl. Again, because this ring is mono-substituted, there's no need to label the number 1 here. So we can just name this isopropyl cyclohexane. Now let's practice naming some di-substituted cycloalkanes. So here are 2 examples of di-substituted cycloalkanes. You may notice I'm using very similar examples to our first examples of the cycloalkanes. So again, here we have the 6-carbon ring. So this would be the parent. Again, this is a cyclohexane. It's a 6-carbon ring. And just like our first example, here's our propyl group. And then you'll notice over here, bonded to this carbon in the ring, I have the 1-carbon alkyl group. And so this is the methyl. At this point, numbering the parent chain is important. We need to tell the reader where these 2 substituents are. But you may notice there may be a little problem here in numbering these. Just like the rules for the alkanes, we want the substituents to have the lowest possible locants. I'll begin here on the left. Let's assume this is carbon number 1. If I count clockwise, this would put my propyl group at carbon number 3. However, you may also notice if I count the propyl group at carbon number 1, then my methyl group, counting counterclockwise, would be at carbon number 3. So again, substituents at carbons 1 and 3. So this is a tie. In order to break the tie, we'll use the alphabetical order rule. M comes before P in the alphabetical order, therefore we'll number this carbon as number 1 and this carbon as number 3. So the name here 1-methyl dash 3-propyl cyclohexane. Again, you'll notice here in our second example, the parent chain is cyclohexane. We have very similar substituents. Here we have the 3-carbon substituent, isopropyl, and the 1-carbon substituent, methyl. Again, we need to number the parent chain. We need to tell the reader where these substituents are located. Again, you'll notice a very similar symmetry to our first example. If I start with the isopropyl, clearly I'll number counting clockwise. So this will be carbon 1 and this will be carbon 2. This will give me the lowest possible locants on the ring. However, if I start with the methyl group as carbon 1 and count counterclockwise, this would give my second substituent at carbon 2. So there's a tie, carbon 1 and carbon 2. So when we have a tie like this, we'll use alphabetical order. In this case, iso is part of the name, and so we'll use the I as our tiebreaker in the alphabetical order rule. So I'll count this carbon number 1 and this carbon number 2. The name here, 1-isopropyl, 2-methyl, cyclohexane. Now let's name some tri-substituted cycloalkanes. So here's an example of a tri-substituted cycloalkane. I'm using the same parent as my previous examples, the 6-carbon ring. The parent here is cyclohexane. And then you'll notice that there are 3 substituents. The 1-carbon alkyl group, the 2-carbon alkyl group, and here we have a 4-carbon alkyl group. The methyl group, the ethyl group, and the 4-carbon substituent, which is a butyl. However, for the butyl group, we notice that the parent is bonded to the secondary carbon. This is called sec-butyl. With the tri-substituted cycloalkanes, we're going to have to run a couple of tests so that we can see where we start numbering the parent chain. If I start with the methyl group and count clockwise, my substituents will be at carbons 1, 2, and 4. Interestingly, if I start with ethyl and count counterclockwise, my substituents are at carbons 1, 2, and 5. If I start with the sec-butyl and count counterclockwise, my substituents would be at carbons 1, 3, and 4. And you can see here, 1 and 2 is better than 1 and 3. We want the lowest possible locants, so this is not an option, starting at the sec-butyl. There's a tie when you start with the methyl and ethyl groups. We have substituents at carbons 1 and 2. However, you'll notice right here, 1, 2, 4 is going to be better than 1, 2, 5. So this is going to be our numbering. 1, 2, and 4. There are a few other ways you can count, but you'll notice that starting with the methyl and going clockwise will be our answer. Now, we still have to name the substituents in alphabetical order. Sec is a prefix that is not part of the alphabetical order rule. In the alphabetical order rule, butyl will go first, ethyl will go next, and methyl would go last. Even though the methyl group is at carbon number 1, we still follow the alphabetical order rule. Four sec-butyl, 2-ethyl, 1-methyl, cyclohexane. Let's take a look at an example where a ring is a substituent and not the parent chain. So the rule still applies. We need to find the parent chain, which is the longest carbon chain. And so I'll start here at the end. 1, 2, 3, 4, 5. We cannot count into the ring. Remember, the ring is its own chain. So I'll continue counting across. This is 6 and 7. Notice that the ring is a 5-carbon ring. 1, 2, 3, 4, and 5. So the parent is right through the center here. The parent is heptane. For the ring, we have a 5-carbon ring. The prefix for 5 is pent, but because this is a substituent, an alkyl group, the name here is cyclopentyl. Notice the suffix representing the alkyl group. I've added two other substituents. Right here we have the wedge and the dash, the wedge representing a methyl group pointing out of your screen, and the dash is another methyl group pointing into your screen. We want to number the parent chain. If I start here, our first substituents would be at carbons 1, 2, 3, 4. If I start counting from right to left, my first substituent is at carbon number 3. Alphabetical order rule. C for cyclo goes first, and then the methyls will go next. The name here, 3-cyclopentyl. There are 2 methyl groups at carbon number 4, so we'll write 4, 4 dimethyl. And we have to write both 4s. We have to tell the reader that there are 2 methyl groups and which positions they are located. And the parent, heptane.